Up to this point, when we've drawn Lewis structures for ions, we've placed the structure of that ion in brackets with the charge outside. I want to make sure you know that there's another way that we could indicate the presence of formal charge or ionic charge in a structure, and it is by assigning the formal charge directly to the atom that bears the charge. And this is how Sapling will want you to include the formal charge in your structures, so that anytime you draw a structure, you should be calculating the formal charge for every single atom, and anytime you have an atom that bears a formal charge, you need to be including that formal charge in the structure that you are drawing in Sapling. For me, for the things that I am grading, you may include the formal charges on the atoms that bear the formal charge. You may place the structure of the ion in brackets with the charge outside, as long as the directions don't specify anything beyond just drawing the best Lewis structure for a compound. Both of those will remain options. If I were to specify formal charge be assigned to an atom that bears the formal charge, this is how you would have to proceed. So that we've seen the structure of the nitrate ion before. We know that our oxygens with 3 lone pairs and 1 bond carry a formal charge of -1. And when it comes to assigning those formal charges directly to the atoms, what we're going to do is we're going to put that negative charge on this oxygen because its formal charge is -1. We're going to put that negative charge on this oxygen. It is my habit to circle charges. It tends to make the charges more visible for students. You may circle, you may not circle. It doesn't matter, but that's how we would indicate the negative charges on each of those oxygens. In this structure of the nitrate ion, we're not done because we also have a formal charge of +1 that resides on that nitrogen. So that if we were to include all of the formal charges, we would have a formal charge of +1 shown on the nitrogen and a formal charge of -1 shown on each of these oxygens with 1 bond and 3 lone pairs. If we were to look at the boryl hydride ion, the atom that bears the formal charge here is the boron, and so we can assign that formal charge to the boron like that. For the nitrite ion, this is one of the Lewis structures that you could draw for this compound. And in this structure, this oxygen has a formal charge of -1. And so I can assign that formal charge directly to that oxygen like so. Ozone is an interesting example because ozone is a neutral molecule. But when we looked at the structure of ozone originally, we also looked at its formal charges. And we know that anytime we see an oxygen with 3 lone pairs and 1 bond, this oxygen is going to have a formal charge of -1. Anytime I have an oxygen with 2 bonds and 2 lone pair, like in water, that oxygen will have a formal charge of 0. And anytime I have an oxygen with 1 lone pair and 3 bonds, this oxygen is going to have a formal charge of +1. So that in the structure of ozone, we have formal charges, but notice that our formal charges do add up to the overall charge of the neutral molecule, and that is 0. So if we were drawing the Lewis structure for ozone and you were asked to specify the formal charges on the atoms that bear the formal charge, this is the structure that you would show.